Now, in this lesson, we continue with our discussion of polygons, the three-sided polygons, namely the triangle. We already had a lot of discussions and lessons on the triangle. Today, we are going to do the last bit, the last bit of triangle. And what is this bit that we would like to investigate? Well, even if we did this a lot of time already, triangles can still be described according to the length of the side. If the length of the side, the three sides have got the same length, that means it's called equilateral. Should it happen that only two sides have got the same length and the third is not the same, then it's called an isosceles, or it's called a what? A scalene triangle. Now, the other thing here is this, triangles happens in such a way that all the interior angles, like here 60 degrees, 60 and 60 there, when you add them up, you must get 180 degree. Just like if this angle was known and this other one and this other one, you would add them up and you still get 180 degree, just like this one here and this one and the other one. You would add the interior angle of a triangle and you get what? 180 degree. A triangle is a polygon with three sides. Polygons can have three sides or more. When you connect three lines or more than three lines together, you form a shape. A shape of that nature is called a polygon. The one we are looking at specifically in this case is a triangle, which is very much a revision of what we already discussed before. Triangles can also be described according to the what? To the angles inside. So the angles inside, should one angle, or should you have a triangle with one angle 90 degree, then it's called a right angled triangle. Should it happen that none of the angles inside the triangle is 90 degree or reaches 90 degree, if all the angles individually is less than 90 degree, then it's called an acute angled triangle. The other type is called an oblique triangle. An oblique triangle is one where one of the angles is more than 90 degree, that is greater than 90 degree, okay? So also in one previous lesson, we looked at this property, which is called the exterior angle property of a triangle. What that property states is that when you add any two interior angle, it must give you the opposite exterior angle. So when you add, for example, angle A and angle B, the opposite angle to A and B is what? Is angle E, meaning angle E must be equal to the sum of angle A and angle B. Now in the second diagram, we have it also similarly indicated, AB, only that it's equal to D, D being the opposite angle to these two interior angles, A and B. Then B and C are two interior angles opposite to what? To F, meaning when we add angle B to angle C, we must get angle F, and also angle C and angle A. There are two interior angles that are opposite to what? To angle E. And so when you add angle A and angle C, you must be able to get angle E. So that one gives us what is known as the exterior angle theorem, or the exterior angle property, that any two interior angles add up to what? 180, rather any two interior angles add up to one opposite exterior angle. Well, with that, we were able to discuss the value of X for activity 1, part 1, part 2, part 3, part 4, and part 5. I requested you to do that. You must have got the value ready, but should it happen that you had difficulty finding it, well, we could do part 4 and part 5, just really quick on that property. So right away, let's get going. Here we go. Just want to find a proper space for our board. Yes, there we go. All right, so when we look at this this diagram here, we see that the opposite angle is 17 minus what? 17 minus X. So we would like to call that one activity 1. Okay, we would like to call this activity 1 part 4. For in this case, it's going to be part D right away. So we say this opposite exterior angle, which is 17x minus 1 must be equals to the sum of 84 degrees and what? And 7x plus 5 degrees. So from here we can find the value of x. And what we get at the end of the day is that if this exterior angle can have a definite value, then the sum of these two interior angles must be equals to that. And so we need to find the value of x. Well, we will collect like terms by transferring 7x from the left-hand side, rather from the right-hand side to the left-hand side. And also we will take 1 from the left-hand side to the right-hand side. So that on the right-hand side, we have 84, 5, 1. So this way, we are going to be able to get 10x onto the left-hand side. That is when we take away 7x from 10x. And on the right-hand side, we will be having 90 degrees. So that way, we can find the value of x. How do we do that? Well, we have to divide 10x by what? We have to divide 10x by 10 so that we can find the value of x. Now, also, what we do is we have to divide this 90 on the right-hand side by what? By 10. When we do that, what we get is going to be the value of x, and that is going to be x equals to 9 in degrees. So yes, that's how we will determine the value of this angle here, x. And so when we have determined that angle, we can now go ahead to investigate. Well, let's see what 17x, okay, 17x minus 1 will be. So 17x minus 1 is going to be 17 times x, that is 17 times 9, 17 times 9. 17 times 9 minus 1. So let's see what we get for 17 times 9 right away here with my calculator. 17 times 9 minus 1. It's going to give us 152 degrees. Yes, 152 degrees. That is what we get for the opposite exterior angle. Well, we already have 84. So let's add 84 to 7x. Now notice that 7 times x is going to be 7 times 9, okay? So we are going to write this as 7 times 9 equals, rather, plus 5. Plus 5. We want to see what we get here. So this is going to be 84 for the first term. Then 7 times 9 plus 5, well, let's get that on the calculator. 7 times 9 by 5. 7 times 9. When we add 5 to it, we get 68. Yes, we get 68 degrees. So we would like now to add 84 to 68. Well, what do we get for that? Well, 84 by plus 68, 84 plus 68, 84 plus 68. Yes, that is 152. So that is the angle property of this. The other one is that you could add these two and it must be equals to what? 130. All right, 130. So when you add these two interior angles, you must be able to get 130. So that one would be activity 1 part E. So we say activity 1 part E. Now this way, we want to find out the value of x, and we would like to find the individual angles inside there. So yes, this is going to give us 130 for the exterior angle, and for the interior angle, we have what? We have 16x plus 4, and also 14x plus 6. Okay, 14x plus what? Plus 6. So this way, we then have in the next step, we collect like terms, meaning we are going to bring 4, which is positive on the left-hand side, and 6, which is also, it's positive on the right-hand side, and 6 also positive on the right-hand side. When we move them onto the left-hand side, they become negative. And on the right-hand side, we will now be left with 16x that we have to add to what? To 14x. Now notice that we are going to have on the left hand side 130 minus 10, which is what? Which is 120. And on the right hand side, we are going to be having 16 plus 14, which gives us 30x. Now in the next step, we now want to find the value of x. So that means we have to do what? We have to divide 30x by 30. So we have to do that so that we can find the value of x. So there we go. That's now the next thing we want to do. So notice that when we divide 30x by 30, all right? When we divide 30x by 30, that also requires us, we will have to do the same onto the left-hand side. Whatever is done on the left-hand side must be done on the right-hand side, and whatever is done on the right-hand side must also be done on the left-hand side. So that way we can find the value of x, and 40 degrees would be the value of x. So we say 40 degrees equals to the value of x. Yes, equals to x. So that's how we find the value of x. So yes, we can now independently check the value of 14x plus what? 14x plus 6. Now 14x plus 6 is now going to be equals to, it's going to be equals to 14 times 40. Okay, that's going to be 14 times 40. Okay, let's see here, 14 times 40 for x plus 6. So 14 times 40 plus 6, right away on our calculator here. Let's see, 14 times 40, to it we are adding 6. Really? Wait. 14x, oh no, this is supposed to be, 4, not 40. This is supposed to be 4, sorry for that. So yes, this is going to be 4. So you see now when we multiply, instead of multiplying 14x as 14 times 40, we are now going to be having 14 times 4. So let's check again, 14 times 4. And onto it we add what? We add 6. This is going to give us 62, which makes a lot of sense, makes a lot of sense. So this is going to be 62. Well, initially it was over 500, and you see the interior angles of a triangle can never go beyond 180 degrees. So that was already what? A problem. Now the next thing for us to determine is the value of 16x plus 4, which is going to be 16x plus 4. 16x plus 4. All right, 16x plus 4. This is going to be 16 times the value of x, which is 4 in this case. That is 16 times 4. Right here, 16 times 4. To it, we are adding 4. We want to find out what is there. So there we go with our calculator. 16 times 4. Okay. And to it, we add 4. That gives us 68. Okay, that gives us 68. Like that. So now we would like to find out what we get when we add 62 to 68. So when we add 62 to 68, well, it turns out that we are supposed to have 130, which is exactly what we have here, So yes, that is just a brief recap, and also a little bit of the correction of the previous work that we did, in one previous lesson. The next thing, or the last bit of our polygon, the three-sided polygon that we would like to investigate is called the area. Now, the area of the triangle is easily calculated when we know the base and the perpendicular height. So notice that in this first triangle, which we are going to call right-angled triangle, just because there is this 90 degree here, please notice that there is an angle here with this small box. This means 90 degree. Here, 90 degrees is somewhere in the middle here, but it helps us to determine the height, okay? The perpendicular height is that height which is formed when the length of the height meets the base at 90 degree, okay? Then here we have the height right away here. So we must be able to get the height first, then later the base. That way we can determine the area. And we can do that in a number of questions as it's indicated here. So please note that in the first activity in this question, all right, So here we have a triangle. Now this triangle is having a base of 5 centimeter and a height of 6 centimeter. Can we determine the area? Yes, we can. All right, so right away, we are now looking at what? The area of a triangle, which we start from here. So we would like to call this activity what? Activity, well, the first activity, part A, for what? For the area. So we say area of a triangle is calculated when we know the base and the height. Okay, so we say this half times, okay, times b, where b is the base, then again times h, okay, where h is the height. Now please note that it's okay to write it as half, rather to write it as b times h. Okay, you can write this as b for the base and h for the height divided by 2. It's perfectly fine to write it this way. In fact, I prefer it this way because it makes the calculation a lot easier to deal with. So let's use that right away. Now for this, we are going to have, for the numerator, we have the base as 5 centimeters, okay? So we are going to write 5 in centimeters, okay? And please note that we are multiplying this 5 in centimeters by what? By the height, which is also in centimeters, but 6 in this case. Then later, we are dividing them by what? We are dividing them by 2. So when we do that, what we get is going to be 30 divided by what? It's going to be 30 for 6 times 5 divided by 2. Now 30 divided by 2 is 15, okay? So you could still write as 30 divided by 2, it's fine, or you can just get the final answer right away. So just one more step there. Let's write it as 30 divided by 2, you know. So this is going to be 30. Now please note that this is now going to be in squared centimeter or centimeter squared, okay? So we can write it as 30 centimeters squared. All right, so let me expand our board a little bit this side. Okay, so there we go. Now this is what I was saying. Then divide by 2. Okay, so this 30 centimeters squared is going to be divided by 2, and notice that we get 15 what? 15 centimeters squared. All right, so that's the unit of area. Area is always a squared unit. So for the first activity, that's what we have, okay? We have 15 centimeters squared. The formula is half base times height, or very much base times height divided by 2. So where there is b, you write the base, you substitute b, which is 5 for this question. And where there is h, we write 6 for this question, where we get 5 by 6 to give us 30. So this centimeter multiplying itself gives centimeter squared, and so we divide by 2 to get what? The final value, which is 50 centimeters squared. Now for the second activity, we would like to call it activity 1, okay? Activity 1 part B. In activity 1 part B, we are equally required to determine the what? We are also required to determine the area. So now to determine the area, all right, to determine the area, we say A for the area, okay, equals to what? Well, equals to base times height divided by 2. And please note that our area is, our triangle is a little bit hidden. So let's bring it right away here on board. All right, so there we go. Now it can be seen with ease. All right, so for this, just reduce it a little bit. Well, there we go. Okay, so one thing we notice here is that the base for our triangle is 4 centimeters, and the height is this, even if it's, you know, turned around or, you know, kind of changed a little bit. So we have the height here. It's a lot easier to see where these two meet. It's 90 degrees. So one of the two is the base and the other one is the height. So we just substitute it right away. And when we do that, for the numerator, we are going to be having 4 centimeters, okay, 4 centimeters for the base, and also 4 centimeters for the what? For the height. So that will give us 4 centimeters times 4 centimeters. And then we have to divide this value by 2. So please note that when we do that, we are going to have 16 centimeters squared for the numerator, okay? We are going to have 16 centimeters squared for the numerator, 16 centimeter squared, okay? Centimeters squared for the numerator. And for the denominator, we are going to have 2. And when we divide 16 by 2, we get 8. So our final answer is going to be 8 centimeter what? Centimeters squared. So that's going to be the value of our area of the second triangle. So for the third activity, well, we are going to call it activity 1, part C. Now for activity 1, part C, well, let's see the diagram right away and we determine what they are really asking for. Okay, so there we go. Now in this activity, what we have is this triangle. Well, the shape of the triangle is not a nice one, but we have to deal with it. So you see, now notice that we have this length here as 3.5 centimeters, okay? And please note that we have this other length as 7 centimeters. Now the perpendicular length is 3 centimeter, okay? The perpendicular length is 3 centimeter, very much like saying from top here up to bottom here is 3 centimeter, but the 3.5 is for the slanting length, okay? For the slanting length. And now because of that, to calculate the area of this triangle, well, the formula will not change, okay? The formula will not change. We are going to use the same formula. And what's that formula? Well, the formula is, wait, right here. Yes, the formula is right here. So the formula is that the area of a triangle is base times height divided by 2, okay? And from here, the next thing is for us now to determine the base. Well, what's the base in this case? Notice that the base is 7 and the perpendicular height there is 3, okay? So we are going to be having 7 still in centimeters, okay? And we are going to multiply, okay? So we are going to multiply this by, all right, so let me first move this a little bit this side, okay? So there we go. Well, I'm looking for a way of expanding this. All right, so there we go. Now we are multiplying 7 centimeters by 3 centimeters. All right, so then this is going to give us 7 by 3 divided by 2. So please note that when we do that, in the next step, we will then be having 7 by 3, which is 21, okay? So this is going to be 21 centimeter, what? Centimeter squared. So this 21 centimeter squared is what we are going to be dividing by 2. So notice that when we divide 21 by 2, what we get is what? Is 10.5. Commonly written as 10,5. This time in centimeter what? Centimeter squared. So this is going to be the what? The area of our triangle in the what? In the third activity. So yes, in the fourth activity, well, let's see. In activity 1, part 4, which we are going to call part D, what are we doing? Just see right here. Part D, right here, yes. So this is part D. So the base is 8 centimeters and the height is 3.5 centimeters. We easily see the height because, you know, the base is meeting, the baseline is meeting the vertical line at 90 degrees. So that perfectly forms the height. So the base is 8 and the height is 3.5. So let's get right away into that. So the base is 8 and the height is 3.5. And so we say from area of a triangle, you know, from area equals to base times height. From area equals to base times height, we can then go ahead to substitute, that is base times height divided by 2. We will then be having 8 for the base, that is 8 centimeters, okay? 8 centimeters. This 8 centimeters, we are going to multiply this, okay? So we are going to be multiplying that with the height. And notice that the height is 3.5 centimeters, okay? Just right here. The height is 3.5 centimeters right here. So we just substitute that times what? Times 3.5 centimeters. So this is commonly written as 3.5 centimeters, like that. So notice that we are still dividing this by 2, and when we do that, what we get is going to be, well, 8.8 times 3.5. We can use the calculator for that. Okay, that is 8 times 3.5. Okay, this is going to be 28. So we can therefore write it as 28 divided by what? 28 divided by 2. So 28 divided by 2, 28 being the numerator and 2 being the what? The denominator. Notice that this is 28 centimeters squared now, because centimeter times itself gives centimeter what? Squared. So that gives us centimeter squared of 28. Then the next thing is to divide it by 2. That way we get 14 what? 14 centimeters squared. Okay, so that's going to be the area of this triangle. Now, after determining the area of this triangle, we can move on to the next activity, which is what? Which is activity 1. This is activity 1, part what? Part E. Okay, so let's see what happens here. Now, in activity 1, part E, the interesting thing is we are still required to find the value of the area. All right. So we have to determine the value of the area. And how do you do that? Well, to determine the value of the area, the formula isn't changing. The formula is area equals to base times height divided by 2. So the question now is, what's the base and what's the height? Now, notice that when you check E carefully, the one thing you clearly notice is that the height is 5 centimeters and the base is 6 centimeters. Okay, we are not looking at this slanting length, we are looking at the length, which is meeting the base at 90 degrees. And so this height forms what? This height forms 5 centimeters and the base forms 6 centimeters. So that way, we can now go ahead to calculate what? The area without any problem. And so we say base times height divided by 2, going to be substituted as 6 centimeters for the base, okay? 6 centimeters for the base, and well, the height, that is times the height, which is 5 centimeters, yes, times 5 centimeters. This one we're now doing what? We're now dividing by 2 right away here. So this way, we can go ahead to determine the what? We can go ahead to determine the area. Please notice that 6 times 5 gives 30 for the numerator. So we have 30 centimeters squared, okay? This is going to be 30 centimeters squared. Now this centimeter squared, which is this, has got to be divided, okay? We have to divide this by what? We have to divide this quantity of 30 centimeters squared by 2. So please notice that when we divide this by 2, what is going to be, or our final answer is going to be 15 centimeters squared. Our final answer is going to be 15 centimeters squared. And yes, this is how we determine the area of what? The area of this 3-sided polygon, which we commonly refer to as a triangle. And yes, this leads us to the end of our discussion for today. Next is going to be another form of a polygon, you know, probably parallelogram or something like that. Otherwise, this has been how to determine the area of what? The area of a 3-sided polygon, which we simply refer to as a triangle.